Greetings to all. In this video again we will be trying to find the axis looking at the ECG. So as I have already discussed in previous videos, to find the axis what I generally prefer is to first draw a lead 1. So this will be your lead 1, and next which I prefer is drawing AVF. So here you have your AVF. So let me level up them. So this is your lead 1, this is lead 1, and this is lead AVF. So now you look at lead 1. So now we jump to lead 1. So here it is our lead 1. So here it is lead 1, and in lead 1 you look at QRS complex. So in QRS complex you see that there is slight positive deflection. However, there is greater magnitude of negative deflection. So the resultant vector will be negative. So when you draw this vector in lead 1, it will be in negative direction. What I mean to say is that now the vector will be moving to this direction. So when we draw that vector, suppose let me draw. So here is the vector moving in this direction. So this is the vectorial representation of QRS depolarization in lead 1. Now we take the example of AVF. So in AVF, so we have our AVF here. So when we see this AVF, there is maximum positive deflection, you see here, and a slight negative deflection. And when you take the resultant, it will be in positive. The resultant vector will again be positive. So the vector direction will be going towards here. So when we draw this in AVF, then this vector will be moving downward. However, the magnitude in AVF will be less because the resultant vector is lesser in comparison to resultant vector in lead 1. So it will be slightly smaller. So here this is our I think it's not quite clear. So this is vector. So this is the vector, this green one, and this red one is the negative deflection vector in lead 1, and this green one is the positive deflection vector in AVF. So now next thing what we are going to do is to draw a perpendicular line. So here I draw a perpendicular line, isn't it, and I draw a next perpendicular line from here, and you can see they meet at this point. So where are they meeting? They are meeting at here, isn't it? So now I draw a resultant vector. So I draw a resultant vector from here to here. So this is our resultant vector which signifies the axis. So when you look at the angle made here, you see this angle is of course greater than 110 degree. So 110 degree must be somewhere here. So it is greater than 110 degree. So it means it is deviating towards the right side. So this is the example of right axis deviation. So differential diagnosis, you can put right ventricular hypertrophy, or it could be because of right bundle branch block. So in this way you can find axis, and you can determine the axis from a given ECG. Thank you.